Okay, welcome class. This is a video on chapter 8, the concepts of chemical bonding. It goes with the PowerPoint. I'm going to do this side by side. Every time I scroll through the PowerPoint, it erases some of the writing, but it'll come back up. So so don't get freaked out if you see the writing go away. So let's get started. Chemical bonding. We have three types of bonds. We have ionic, covalent, and metallic. Ionic we can refer to as stealing electrons. Covalent as sharing electrons. And metallic as a group sharing electrons. So imagine the entire group of iron all sharing their electrons across all iron. We also refer to this as an electron sea. It's like an ocean of electrons just flowing back and forth. One way we commonly discuss different electrons in different locations is through the Lewis structure. Another word that we've used so far is the electron dot diagram. They're about the same thing. For our purposes, they're the same. So, Lewis structures. Lewis structures refer to the number of valence electrons around each atom. So for sodium, it has a 3s1 valence shell configuration, indicating Na with a 1 dot. There's 1 electron, 1 dot. Something like silicon has 3s2, 3p2. There we go. There's a total of 4 electrons around it. So another way of looking at this is the number of columns. So these show us where the electrons are and how their bonds are going to be made. All right. Moving on. Ionic formation occurs when they're going to create ions. So an ionic bond is going to be creating ions, specifically a cation and an anion. How does it do that? Well, as we notice on our electron dot diagrams over here, the electron is stolen by the chlorine, and we end up having 2 electrons over here. Also, the number of protons creating a minus charge and a plus charge. Here's our cation, and here's our anion. So we created 2 ions. We stole an electron from one to another. This is a very strong bond. More specifically, it's a strong attraction. So a strong attraction between a positive and negative, just the same way as negative and positive magnets. So another way of creating, when these ions are created, they create a lattice, which kind of refers to some sort of matrix of positive and negative ions. We will have a positive next to a negative, next to a positive, next to a negative, and vice versa on the shell below it. And we can think of this kind of like a salt cube. It creates this matrix of different charges, and this is what we consider a lattice. Lattice energy specifically, I want to go into lattice energy? I don't think so. We'll leave it there. This is a lattice. It creates this matrix form of different levels of positive and negative. So that's pretty cool. Let's see here. Lattice energy, of course, we're not going to talk too much about this, but we can measure it as electrostatic interactions of positive and negative. There's different amounts, whether they're charges or ions or decreasing size. Very interesting. Cool, covalent bonds. Covalent bonds, as we referred to before, are sharing, and they're normally between a nonmetal plus a nonmetal. when ionic is more so between a metal and a non-metal. We talked about that before. Cool. So overall, as it says on the slide, covalent bond is a combination of the attractions between positive and negative charges and the repulsions between positive, and negative, charges. What we have here is oversharing of electrons. Another way of looking at it is an overlap of electron orbitals. This is what we consider another way of sharing electrons. Now, just to touch on it, another way we talk about this is sp orbitals can hybridize. And this also indicates more sharing of electrons. And so I don't want to talk too much about hybrid orbitals, but just so you folks know, when you hear hybridization, we're usually referring to covalent bonds between nonmetals, and that's the s and p orbitals that are hybridizing together to create this sharing atmosphere, which is really, really important. Let's see here. So, polar covalent bonds, this is going to refer to the change in electronegativity. Now, if we remember electronegativity, that is going to be the pull of electrons. So if we can imagine one element, if we cut an element in half, or a molecule in half between both elements, this one has a much higher electronegativity. It's going to pull more, and it will create this somewhat of a dipole of electrons. So pulling electrons to one side creates what we consider a partial negative and a partial positive. And we denote that this way. We also referred to this before as a dipole moment. That's referring to the length between the positive and negative charges. This symbol right here, it means partial. And so if we do have, an element right here with some electrons in a bond, this is element X, this is element Y, I'm just making these up. And if this one is more electronegative, these electrons will slide over into here, creating a partial negative and a partial positive. So we can easily figure out which ones are more electronegative. If we look on these tables, we notice that our electronegativity trend goes up and to the right across the periodic table. That way. So we can easily look and say, oh, well, we know that fluorine is more negative than, say, hydrogen, and so, or fluorine is more negative than boron, electrons are going to be pulling toward fluorine, creating a partial negative side. That's a polar covalent bond. Still sharing of electrons, but they're more toward one side. A completely polar bond is another way we can talk about an ionic bond. Ionic bond, usually between a metal plus a nonmetal. And based on the periodic table, we know the nonmetals have a higher electronegativity, so it's going to pull more electrons over here. It pulls so hard it actually reaches out and steals the electrons, forming a metal cation plus a nonmetal anion. So that's the full pull. Polar bonds, a full polar bond is an ionic bond, but you can have a partially polar bond and a polar covalent bond. And we're still sharing the electrons, hasn't quite pulled it all across. Okay, so that is a quick video on chapter 8. Now I'm going to stop it here. The next video is going to refer to Lewis structures and how to draw them and how to write them. All right, thank you. We'll see you next time.